Hi guys, welcome back. In the previous lecture, we have learned how to generate Golang CRUD code to talk to the database. Today we will learn how to write unit tests for those CRUD operations. Let's start with the create account function. I'm going to create a new file, account_test.go, inside the SQL C folder. In Golang, we have a convention to put the test file in the same folder with the code, and the name of the test file should end with the test suffix. The package name of this test file will be db, the same package that our CRUD code is in. Now let's define function test create account. Every unit test function in Go must start with a test prefix with uppercase letter T and takes the testing.t object as input. We will use this T object to manage the test state. The create account function is defined as a method of the queries object, and it requires a database connection to talk to the database. So in order to write the test, we have to set up the connection and the queries object first. The right place to do that is in the main test.go file. I will define a test queries object as a global variable because we're going to use this extensively in all of our unit tests. This queries object contains a dbtx, which can either be a db connection or transaction. In our case, we're going to build a db connection and use it to create the queries object. Alright, now I'm going to declare a special function called testMain, which takes a testing.m object as input. By convention, the testMain function is the main entry point of all unit tests inside one specific Golang package, which in this case is package db. Okay, now to create a new connection to the database, we use SQL.open function and pass in the db driver and db source string. For now, I'm just gonna declare them as constants. In the future, we will learn how to load them from environment variables instead. The db driver should be Postgres, and the db source we can copy from the migrate command that we've written in the previous lecture. Alright, the SQL.open function returns a connection object and an error. If error is not nil, we just write a fatal log saying we cannot connect to the database. Else, we use the connection to create the new test queries object. The new function is defined in the db.go file that SQL C has generated for us. Now the test queries is ready. All we have to do is to call m.run to start running the unit test. This function will return an exit code, which tells us whether the test passed or failed. Then we should report it back to the test runner via the os.exit command. Okay, let's try to run it. We've got an error, cannot connect to db, unknown driver Postgres. This is because the database SQL package just provides a generic interface around SQL database. It needs to be used in conjunction with a database driver in order to talk to a specific database engine. We are using Postgres, so I'm going to use Libpq driver. Let's open its GitHub page and copy this go-get command. Run it in the terminal to install the package. Now if we open the go.mod file, you can see Libpq is added here. It says indirect because we haven't imported and used it in our code yet. So let's go back to the main test.go file and import the Libpq driver. This is a very special import because we don't actually call any function of the Libpq directly in the code. So if we just import like this, the Go formatter will automatically remove it when we save the file. To tell Go formatter to keep it, we must use the blank identifier by adding an underscore before the import package name. Now if we run the test main again, there's no more errors. And if we open the terminal and run go mod-tidy to clean up the dependencies, we can now see that the required libpq in go.mod file is no longer indirect, since we have imported it in our code. Alright, now the setup is done. We can start writing our first unit test for the create account function. First, we declare a new argument, create account params. Let's say owner's name is Tom, the account balance is 100, and the currency is USD. Then we call testQueries.createAccount. pass in a background context, and the argument. This test queries object is the one we declared in the main test.go file before. And the createAccount function returns an account object or an error as result. To check the test result, I recommend using the testify package. It's more concise than just using the standard if-else statement. So let's copy this go-get command and run it in the terminal to install the package. Alright, now to use this package, we need to import it first. Testify contains several subpackages, but I'm just gonna use one of them, which is the require package. With this import, we can now call require.noError. Pass in the testing.t object and the error returned by the createAccount function. Basically, this command will check that the error must be nil, and will automatically fail the test if it's not. Next, we require that the returned account should not be an empty object. After that, we would want to check that the account owner, balance, and currency matches with the input argument. So we call require.equal, pass in t, the expected input owner, and the actual account.owner. Similarly, we require balance to be equal to account.balance, and currency to be equal to account.currency. We also want to check that the account ID is automatically generated by Postgres. So here we require account.id to be not 0. Finally, the created@ column should also be filled with the current timestamp. The not 0 function will assert that a value must not be a 0 value of its type. And that's it. The unit test is completed. Let's click this button to run it. We see an OK here, so it passed. Let's open the Simple Bank database with Table Plus to make sure that a record has been inserted. Here it is. We have an account with ID 1. The owner, balance, and currency values are the same as we set in the test. And the created@ field is also filled with the current timestamp. Excellent. We can also click Run Package Test to run the whole unit test in this package. For now, it just has only one test. But the nice thing is, the code coverage is also reported. At the moment, our unit tests cover only 6.5% of the statement. If we look at the account.sql.go file, we can see that the createAccount function is now marked with green, which means it is covered by the unit test. All other functions are still red, which means they are not covered. We will write more unit tests to cover them in a moment. But before that, I'm going to show you a better way to generate test data, instead of filling them manually as we are doing for this createAccount argument. By generating random data, we will save a lot of time figuring out what values to use. The code will be more concise and easier to understand. And because the data is random, it will help us avoid conflicts between multiple unit tests. This is especially important if we have a column with unique constraints in the database, for example. Alright, let's create a new folder, util, and add a new file, random.go, inside it. The package name is util, same as the folder containing it. First, we need to write a special function, init. This init function will be called automatically when the package is first used. In this function, we will set the seed value for the random generator by calling run.seed. Normally, the seed value is often set to the current time. As run.seed expects an int64 as input, we should convert the time to Unix nano before passing it to the function. This will make sure that every time we run the code, the generated values will be different. If we don't call run.seed, the random generator will behave like it is seeded by 1. So the generated values will be the same for every run. Now we will write a function to generate a random integer. This random int function takes two int64 numbers, min and max, as input, and it returns a random int64 number between min and max. The formula is min plus run.int63n max minus min plus 1. Basically, the run.int63n function returns a random integer between 0 and n-1. So run.int63n max minus min plus 1 will return a random integer between 0 and max minus min. Thus, when we add min to this expression, the final result will be a random integer between min and max. Next, let's write a function to generate a random string of n characters. For this, we will need to declare an alphabet that contains all supported characters. To be simple, here I just use the 26 lowercase English letters. Now in the random string function, we declare a new string builder object, sb. Get the total number of characters in the alphabet and assign it to k. Then we will use a simple for loop to generate n random characters. We use run.int_k to get a random position from 0 to k-1 and take the corresponding character at that position in the alphabet. Assign it to variable c. We call sb.writeByte to write that character c to the string builder. Finally, we just return sb.string to the caller, and the random string function is done. We can now use it to generate a random owner name. Let's define a new random owner function for this purpose. And inside, we just return a random string of 6 letters. I think that's long enough to avoid duplication. Similarly, I'm going to define another random money function to generate a random amount of money. And let's say it's going to be a random integer between 0 and 1000. We need one more function to generate a random currency as well. This random currency function will return one of the currencies in this list. Here I just used 3 currencies, Euro, USD, and CAD. Similar to what we've done to generate a random character from the alphabet, here we compute the length of the currency list and assign it to n. Then we use run.int_n function to generate a random index between 0 and n-1 and return the currency at that index from the list. Alright, now get back to the account test.go file. In this create account params, we can replace this specific owner name with util.randomOwner. This balance with util.randomMoney, and USD with util.randomCurrency. And that's it. Now if we rerun the unit test and refresh table plus, we can see a new record ID 3 with random values. The first 2 records are fixed values because we had run the test twice before we used random functions. So it works. Now I'm going to add a new test command to the make file so that we can easily run unit tests in the terminal. The command is simple. We just call go test, use a v option to print verbose logs, and cover option to measure the code coverage. As our project is going to have multiple packages, we use this /../ argument to run unit tests in all of them. Now if we run make test in the terminal, we can see it prints out verbose logs whenever a test is run or finished. It also reports the code coverage of the unit test for each package. Now let's refresh table plus to see the new record. It's a complete different value from the previous record, so the random generator is working well. Next, I will show you how to write unit tests for the rest of the CRUD operations. Let's start with the getAccount function. You know, to test all of other CRUD operations, we always need to create an account first. Note that when writing unit tests, we should make sure that they're independent from each other. Why? Because it would be very hard to maintain if we have hundreds of tests that depend on each other. The last thing you ever want is when a simple change in a test affects the results of other ones. For this reason, each test should create its own account records. To avoid code duplication, let's write a separate function to create a random account. Paste in the code that we've written in the test create account function. Then for this test, we just need to call create random account and pass in the testing.t object. Note that the create random account function doesn't have the test prefix, so it won't be run as a unit test. Instead, it should return the created account record so that other unit tests can have enough data to perform their own operation. Now with this function in hand, we can write unit tests for the getAccount function. First we call create random account and save the created record to account1. Then we call testqueries.getAccount with the background context and the ID of the account1. The result is account2 or an error. We check that error should be nil with this require.noError function. Then we require account2 to be not empty, and all the data fields of account2 should equal to those of account1. We use require.equal function to compare them. First the ID, then the account owner, the balance, and the currency. For the timestamp fields like created at, beside require.equal, you can also use require.within duration to check that two timestamps are different by at most some delta duration. For example, in this case, I choose delta to be 1 second. And that's it. The unit test for getAccount operation is done. Let's run it. It passed. Now let's write tests for the updateAccount function. The first step is to create a new account1. Then we declare the argument, which is an updateAccount params object, where ID is the created account's ID, and balance is a random amount of money. Now we call testqueries.updateAccount, pass in a background context and the update arguments. Then we require no errors to be returned. The updated account2 object should not be empty. And we compare each individual field of account2 to account1. Almost all of them should be the same, except for the balance, which should be changed to argument.balance. Alright, let's run this test. It passed. The test delete account can be easily implemented in a similar fashion. First we create a new account1. Then we call testqueries.deleteAccount and pass in the background context as well as the ID of the created account1. Require no errors. Then to make sure that the account is really deleted, we call testqueries.getAccount to find it in the database. In this case, the code should return an error, so we use require.error here. To be more precise, we use require.equal_error function to check that the error should be SQL.error no rows. And finally, check that the account2 object should be empty. Now let's run the test. It passed. Excellent. The last operation we want to test is listAccount. It's a bit different from other functions because it selects multiple records. So to test it, we need to create several accounts. Here I just use a simple loop to create 10 random accounts. Then we declare the listAccount parameters. Let's say the limit is 5 and offset is 5, which means skip the first 5 records and return the next 5. When we run the test, there will be at least 10 accounts in the database. So with these parameters, we expect to get 5 records. Now we call testqueries.listAccount with the background context and the parameters. Require no errors. And require the length of the return account slice to be 5. We also iterate through the list of the accounts and require each of them to be not empty. And that's it. Let's run this test. It passed. Now let's run all unit tests in this package. All passed. If we look at the account.sql.go file, we can see that all account CRUD functions are covered. But why the total coverage of this package is only 33.8%? That's because we haven't written any test for the CRUD operations of entries and transfers tables. I leave it as an exercise for you to practice. I hope this video is useful for you. Thanks for watching and see you in the next lecture.